Hello everybody, my name is Lauri Ilison. I would like to give you during the 40 minutes about short what's the machine learning and how to use it in the cloud. First I would like to start with a short quiz. Raise your hand if you have used any machine learning in your daily work, in your applications. Good. Then I have at least something to tell you. The reason why we just propose to have that kind of theme on the agenda is that actually it's something that in the cloud, especially in the cloud, when we have large-scale services, applications use a lot. Companies are really investing in this, finding the way how we could use data generated by the customers, devices, whatever, for the business purposes. And I have a couple of examples for you. For example, the world's largest machine learning project, so to say, is a Google search engine. Part of the machine learning tools, they are giving us so good search results. Even we are searching for different keywords, different themes, they do it pretty well. Just as a second example, Facebook uses machine learning in their photos. They get daily 350 million photos, and based on this they have a vision that they would like to understand what is on the photos. We know that they are recognizing their faces, that's true, but they are doing on the concrete person level. Even more, they can actually detect the objects and where the objects physically are in the world. And their vision is to build the knowledge to know what is happening in the world. And they have really big source of data for this. And they are really doing. They actually launched the Artificial Intelligence Lab last November, so a year ago, and just expect soon the first outcomes coming to the application. The fourth example that I have is that sport is using the machine learning. You know, remember this game between Germany and Brazil, this championship in the summer, and this disaster, 7-1. And how actually Germany did was that they, before the match or the championship, they actually measured all the competitors from the videos. They took up the player by player, how the players are moving on the ground. And they understood that they actually, in order to compete, they need to change their game. And what they did, they actually decreased the average possession time from 3.4 seconds to 1.1, making the game much faster. And it was some kind of surprise for others. And such a way they were able to win. So expect similar things happening in next championships. If you use Spotify, then those lists that they are on a shuffle mode providing you, for example, are based on machine learning. The other user's preference is used to compile a list for yourself based on your past listened songs and the other persons with a similar taste. And if you feel that the list is not good, then just you need to teach them. You need to tell to the application what you like. Just listening specifically the songs that you like. Behind that, there are a lot of algorithms used. And I would like to, in the following 20 minutes, I would like to show you the principal algorithms which are behind that kind of machine learning. Starting from the simplest example. If you have studied in Tartu University, then they are reading there this data mining course, and also something in Tallinn Technical University. Has anybody taken the course? Good. 3, 4, good, 5. So, just telling you what's the machine learning. In general, you can divide the machine learning in two principal parts. The first part is about supervised learning. It's that kind of situation where you have a sample cases and you have a feedback. Like in the banking, we have applicants for the applying for the loan, and we have a feedback. Who was in default, who repaid and who didn't. And now we are looking for the rules, telling from the app application data who will be probably in default and who will not be. There we can use a classification, regression, and decision trees. The other area of machine learning is something that we have the sample cases, but we don't have the feedback. Just we have customers, and we don't know who actually bought something. But we can still use the algorithms, finding the similar. It's something like our marketing guys are doing the segmentation. Whom we should deliver some kind of offer. Who are actually behaving on a similar way. In this area, we can use a clustering, looking similar customers. We can use hidden Markov change, looking at the behavior over a time and predicting the possible next move. We can use dimensionality reduction and other algorithms. There is actually a very long list of algorithms that you could be applying. Just to visualize this, I have the first and the most simple example of machine learning. It may sound a stupid example, but just a principle thing. So let's assume that we are asked to tell what is the price for 46 square meter flat or apartment. If we had any equation for that, we could do that. But unfortunately, we don't have. But what we have is something from the market. So we have some sample deals. Let's say for the last month or two, from the market saying what kind of deals, what kind of purchases have been actually appearing. And based on this data, we would like to learn what could be the possible relation. And based on this relation, we could tell what is the price for 46 square meter. And what we do, we make assumption that the relation is actually linear line. It's not any polynomial or whatever, any other, but it's basically a linear line, and would like to put it through the data. And we're looking for an equation where price is equal to constant A multiplied by size plus B. And if I have the constant A and B, then I have the so-called machine learning model. I need to find the values for A and B. And I will do that in a simple way. I'm looking for that kind of coefficients which will make the smallest total error between the sample and my hypothetical relation. So the total sum of red stripes should be as minimal as possible. And if I do that, then I could actually tell you that, fine, this is the price. The price is 56k. They do it a lot. Actually, if you have purchased any real estate property in Estonian legal environment, there is this kinnisvara hindamise akt. Actually, they have done that similar there, but only with 3 or 4 samples. But they do that. This is one-dimensional case. If you go to the realistic world, then you have multiple dimensions. So meaning that the price doesn't depend only on the size, but the location, number of rooms, size of the bedrooms, whatever. It might be 6, 10 variables, but it might be also 200 variables. For example, if you think about the web behavior, then all Google Analytics statistical elements up to 250 elements could be the actual so-called features telling or identifying the possible pattern. Okay. The next example that I have for you is about clustering. In case of clustering, we have a certain data set and would like to see that kind of clusters of data that belong or where are close as possible. And if you do it in multi-dimensional case, you can actually find that your customer base, customers in your customer base might actually have a similar behavior. I will show it in the demo now. Just I will switch to the tool and show it to you. I'm using in this example MATLAB, And I have prepared a demo for you. So I will run it 3 times, then you will see that how it actually works. So this is my dataset. In 2-dimensional case, just visually you can see that there are 3 clusters. But I'm going now to search those, and I don't know where they actually are. What are the actual centers of those clusters? So what I do, I randomly select first 3 centers of my clusters. Those are those black things. I'm now coloring, please.
Where did the number 3 came for these clusters? Did you know beforehand that you had 3 clusters?
Yeah, I actually, this is one way. This is one of the tasks. How many clusters should I have? I have done a lot of measurements and verifying that the 3 is best for this case. Sure, this is also issue that how many clusters I have. But visually, just I would like to demonstrate this. Let's assume that I know that most probably I have 3 clusters. I could also run it for 4 and 5 and 6. But just to show you how it actually works without that kind of exactly telling where to start. So what I do, I just select 3 random points in my space, and I'm now coloring the closest data elements, respectively green, red, or blue. And now what I do, I will take this center and move this to the center of those red points on the next iteration, and recolor the closest places. And doing it like stepwise, I will actually receive to the center of the cluster. Now I will do it. I should be doing it once more. Now I'm selecting randomly different starting points. So those are my starting points. And you can actually, as you can see, the things move to the right place. This is the next example. So the message is, independently where I started, I actually come up with the actual places. As you asked, the number of clusters is definitely important, but there are techniques to measure how many clusters you should have. But such a way, I could measure or find out my cluster without assuming that our target group is male between 45 to 50 for the next posting. But now actually measuring what should be that kind of similar behaving customers. Okay? This is about the clustering. There are different algorithms to do that, how to make it stepwise, how to measure the centroids, but basically this is the machine was learning out of the data. The next example is about creating the loan decisioning algorithm. The way how banks actually do that. If you go to the bank, they have done like this. So let me just explain you how they do. They are using logistic regression, and they start with creating the credit scoring model from the past data. I just made a data table here with 16 parameters called P1, P16, and independent of the actual content, I put some numbers there. And on the last column, I have a feedback. Was the customer concrete applicant in default, or he wasn't? If there is a 0, it wasn't default. It was a 1, it was then a bad loan. Now I would like to draw up a model where I could just or apply a new applicant, and that the model will tell me it will be bad or good. And what I do, I'm actually now modeling this with that kind of logistic function, which is with a form like this, and this is the graph of this. Logistic function is always between 0 and 1. If we are in minus infinity, then it's 0. If we are in infinity, then we are having a 1. So it's always between 0 and 1. And based on that, the height let's say if we have a value for 0.5, the height of here could be actually interpreted as a probability, because the total one is between 0 and 1. Okay, now what I do, I will create the model based on this data. And what I do, I will actually, first step, I will split this data set into two parts. The first one is 80% of the rows, and this will be used for creating the model. And the second data set is for verifying the model. This will be 20% of the rows. I will create the model based on those 80% of the rows, and now make a prediction based on this model for this 20% of the rows. And I will come up with an error matrix saying that those are actual values for those 20%, good loan, bad loan, and those are my predicted values based on this 80% having the model and then predicted to 20% of the rows. Good prediction, bad prediction, and I will have this true positive, true negative. In this case, it was a bad loan or it was a good loan, and I predicted a good loan. Here, it was a bad loan, and I predicted bad loan. Here it is a bad loan that I predicted good, and here is the good loan predicted bad. Machine learning algorithms never can be 100% accurate. There's always some kind of error. If you are in the bank, you will run the algorithm with a 75% of accuracy, and you will be fine. If I do it selection of tests or this training set and test set randomly for several times, just doing it several times, and I still have the same size of my total error, meaning the sum of false negative and false positive multiplied by a whole number of test rows or test samples, then I must say that actually my model is stable. Independently of selected rows or selected samples, I still get the same error rate or accuracy rate. Okay? I will show it to you. So this is now the second tool that I'm using, just to show you that you could be using different tools. This is the R. Has anybody used the R? Good. Good. This is the R. I'm using RStudio. I have created here a model. Oh, sorry. This was the wrong thing. Okay. This is the right one. This is this is just the code, and actually 50% of this is just stopping and going. I will start running it, and I will tell you. So basically, what I have is I'm loading the dataset. I'm using one German bank dataset with 1,000 rows. There are 20 factors, and the factors for the dataset are as follows. So it consists of, for example, status of existing checking account, duration in months, credit history, purpose, credit amount, and so forth. The data itself will look like this. So just I'm coming up with 20 first rows. As you can see, status of existing checking account is a factor with different labels. The duration in months is a continuous variable, and so forth. There are actually a lot of factors describing each and single application data. And on the last column, I have the figure for was the loan in default or not. If it was 0, it was a good loan. If it was 1, it's a bad loan. And now my task is to create a scoring model based on this data and tell for the test set what kind of loans are bad or good. Just continue running I have also the correlation plot, but it's not important. So I'm just starting the model. Now, actually it does really quickly. So just showing you the figures for the coefficients for the values is that if you have application with status of existing account with value of negative, you will get that amount of points, and you will take grab that kind of points over all the variables, sum up, and it will be between 0 and 1. So a couple of those values are with a minus, so they are decreasing your score. A couple of those are with plus, they are increasing your score. Okay. It's interesting. That's getting me some electricity. Okay. And just to give you, when I was what I did, I split the 1,000 rows into two parts. 800 for the training set and 200 for test set, and now I'm coming up with the error matrix that those are values for 200 rows with good loans, bad loans, and those are my predictions. So 85 of those are such that it was a good loan and I predicted good loan. With 51 it was a bad loan and I predicted bad loan, and those one are now the wrong predictions, either sides. And then just finally showing you the actual values for those are now as you can see, my row numbers are here randomly. Those are 200 randomly selected loans for the test set. And I could come up with the actual figure. So this is the column for the actual value, and this is my prediction. I don't know, can you see it on the last row? But just I wanted to show that we actually can measure by each and single application what is the prediction. And I just put here the three highest scored values. So different applications get the highest score on different elements. This is something that banks are doing. The issue is with the banks currently is that they use too few features, or the factors, meaning that they only take 8 parameters about the person. Gender, education, location, income, and maybe some other. But actually the issue is that those 8 or 9 what they use, they actually don't differentiate the applicants too well. For example, there was one company having a back office in Tallinn and selling fast loans in UK. There are a couple of those. There was a case I just heard. There was a case that they were struggling with the fraud, and on those cases where the applicant made a sign up for the newsletter was actually fraud, because human beings don't do that. But if you are like a credit modeler, then the data, that kind of fact doesn't seem to be so obvious that you need to take it into account, and most probably they don't, and then they cannot actually have that kind of valuable information in the models. So the issue is that we need to have as much as possible those features or the elements describing the behavior. Okay. So what else can you do? You actually can predict the missing data. If this is your initial data set that you have, you know how your customers are doing, then you can make a decision tree and then predict for the next customer where you don't know the actual activity, what he will do. You can predict certain things. For example, in States there's a company selling email marketing addresses or the target list, and they have somehow grabbed the emails from the web, and then they are predicting based on other data what is the gender, what's the age of behind this email, and so on. Next example is about customer churn in telecom. That's the huge issue, that how to see who will be leaving. And here they also use the decision tree algorithms. And the issue is that they have data about the customer. They now manually, or by some rules, they say that this customer has left. They define this on the database. For example, I have here a realistic data set with just a bit beautified figures that you wouldn't see who is the actual owner. So gender, age, car type, brand type, sales in euros, purchase frequency, purchase number, and then on the last column, was the customer churned or not? And now we are coming, I would like to try to actually create a decision tree algorithm in order to predict, will you be, knowing your data, those columns until this row, column, knowing your data, will you churn or not? And businesses could use those algorithms to, for example, to price the next offers. If you are likely to churn, why shouldn't we offer you better conditions getting you back? But if you are likely not to churn, then we'll give you a full price. Actually, they do that. If you haven't seen, if you haven't recognized, they actually do that. Just an example in the live environment, just to show you. Just to show you how it works. So the same example that I have on the list. So this is the code, and let me run that. So now I'm loading the data set. It's a bigger one. There is 400,000 rows with the same data. As you can see, the same data. Gender, age, car type, brand type, sales total, purchase frequency, purchase number, and is it churned or not? Somebody has told, is it churned or not? And now I'm trying to generate the decision tree for that. It will take a while, a bit, because I have a data now. Okay, now I have them. So now I have the decision tree, and the decision tree looks like this. Just I will tell you that it starts from here. So if the purchase frequency is bigger than 94 and purchase frequency is higher than 152, the customer is churned. But if it's below the 152, then we will go deeper and deeper. The tree itself could be actually very, very deep. And you cannot do it anymore in the Excel filters. It just doesn't fit. Even you cannot figure out the rules, because I was doing by the computer, by the algorithm. And those two figures here are actually, the first one is how many customers are in this subsegment. And the second figure is how many customers actually I predicted wrong in this segment. And as you can see, the rules are really deep. The deepness of the tree depends on certain coefficients that I need to configure, saying that how small should be the smallest group, for example. On the current tree, I have defined it for 15. If I'll do it for 5,000, I will definitely get the smaller tree. And it also actually automatically verify the algorithm. And this is that kind of error matrix for classification, yes and no. So it made a model and made the prediction for the training set. So you can see that I wasn't fully right. I still had places for being wrong, but that's fine. The good news is that I have pretty many places where I was right. So actually they do that kind of things in telecom a lot, and they do it even with us. So the next thing what you could be using is the detecting for outliers. There are certain data that statistically doesn't fit into the sample case. They might be typing errors, but it might be also the fraud. So there are algorithms for detecting that kind of outliers from the data sets. You could do it on the time series analysis, decomposing the data on this graph into a seasonal, into a trend, and into a reminder. If you have data long enough, you can do that. Sure, it might not be right because you have some events happening, but you can do that. You can actually come up with a hidden Markov change with that kind of status changes. So if there is a data, historical data about based on weather conditions, what kind of sport will you do? So you can actually draw up the hidden Markov chain algorithm saying the probabilities. If you have arrived here, what will be your choice? If it's rainy, then you do nothing, but you also may move ahead. It might be the case to use it in the web pages. What's the next most probable click that the customer will do, for example? What's the next most probable ad that we should show? Neural network is definitely something that is valuable, but it takes now a bit more complicated, so I will skip it. If you are interested on the subject and you are asking me, okay, what kind of tools should I use? Then I will tell you that this is just a random list, and this is not exhaustive one. Definitely, there are a lot more, but I will recommend to use the R. There are a lot of literature out of that. You can use MATLAB, which is unfortunately a commercial product, but very good one. You can use Python. There are several libraries for that, especially scikit-learn and MLPy. Knime, RapidMiner are GUI-based tools. SPSS is an IBM product. You can use that one. You can use Vectra. SIS definitely is a very expensive one. And others. You also can use it on top of the Hadoop. Is anybody using Hadoop? You know, Hadoop is this distributed computing grid developed by Google, then open sourced or re-implemented by guys, and then open sourced. Definitely, if you have with R, for example, you have issue that you can make predictions on the data that fits into your memory. But if it doesn't anymore, then you need some kind of distributed grid in order to compute. And you can use the Hadoop for that, because there are several libraries that actually fit into Hadoop clusters and can make machine learning algorithms, like Mahout, which is a Apache Foundation project, Spark, the same, they have MLLeap library. GraphLab is a very good tool for computing graph-based things. WhoppleRabbit is Yahoo developed thing. R can actually live on the cluster, and HashiCorp is also the thing. Even more, if you are interested to use that kind of just cloud-based services or SaaS tools, you can use, for example, this Microsoft Azure. They launched their machine learning tool early, was it in July or something like that. There are other startups providing that kind of SaaS-based machine learning libraries. Topconf, BigML, even Google is providing the prediction API. You feed into your training set, you get the predictions later on. Visor and others. If you are interested to start somewhere, this is my recommendation for you. So look at tutorials. There are a lot of there out of. Actually, books are good, really. There are online courses about the machine learning. If you haven't taken or haven't reviewed them, do it. Coursera, for example, has very good things. Even you cannot complete the homework, at least you can review the lectures, which will tell you how people do that. Experiment, and if you're really good, there are also competition sites like Kaggle.com, which where you can actually participate and you can compare your results. The thing there is that there is a competition, you get the training set, you get the test results, you do your modeling, and then submit your predictions, and then they will verify how good you were. And then they will make a leaderboard. That's really good, self-assessment, how good you are. And even more, if you are interested, actually, we are building up the machine learning and big data business unit in Nortal, and we have found several very interesting tasks. We see that this is something that businesses now are really clocking. They really like that, and we can actually serve them. So, if you are interested in the subject, join us. I will guide you through the area, and it will be really interesting to do that. Thank you. By the way, any questions? Yeah, please.
This data needs to be very reliable, right? I mean, pretty exact. What if you have mandatory data, non-mandatory data? Your prediction will be very dependent.
In machine learning, crap in, crap out. Agree. So if you have a crappy data, nothing good will come out. But if there are mandatory data of that kind of, you can still verify. For example, if part of your Loon applications have certain fields, you can actually see, are they realistic? Are they belong to the same distribution of the data? You still can actually verify just from the long perspective, seeing that, can you use those variables or not? Are they affecting or influencing the actual default or non-default? But sure, have the smartest out of mess. It's always a difficult thing.
I have another question about this dependency on understanding what data is, how independent or how decoupled this methodologies are from knowing what the data about.
The issue with the machine learning is that if I will give you the data, and you will try to apply your algorithms, your vision, scope of your understanding is just about the data. Sure, you need to know what is there, but if I will not give you a, let's say, 10th column of the data for the dataset, then you wouldn't figure out what's the actual value for that, how it depends so you cannot replace the algorithm or a human being with the algorithm. You can use the tools to be more efficient, but you still need to keep the common sense that we might have something missing. Let's grab some other data. Any questions? Okay. No.
Besides the examples that you brought, like predicting loan outcomes and making better recommendations for marketing, can you bring other examples that big data is used or can be used here in the context?
For example, like in manufacturing, when, as you are there partly a bit, for example, in manufacturing, we have a production line. It's kilometers long. Something is breaking the machine inside or in the middle. Can we actually see or predict when something will happen? We have past knowledge, and we can say that no, in those conditions, it's a higher risk that the concrete machine will break. For example, you will use a bit different configuration for the metal. It's stronger, it's harder, whatever. It might be tricky for the machine. Actually, those manufacturing companies are using a lot of focus on this. How to ensure that nothing happens. Okay, good. Okay, thank you. And if you're interested, just join us.